Hello everybody, and welcome to another session on transportation planning. We're busy with another method known as the Fratar Method to help us to determine the future trip matrix. In this example, as previously, we're using the same example, except now we're doing the Fratar Method, and the objective of the Fratar Method is to determine a matrix that will fit our future trip totals. In this example, we can only really do one iteration, as you will become knowledgeable from experience. In this example, we are presented with the same trip matrix, and our focus is to generate a matrix that will best fit our future totals as indicated in red. With Fratar, we want to develop a relationship between our row at A, destinations, and its base totals and future totals, and we want to parlay that relationship into one with the origins at A, totaling a future total of 91. So we want to develop a ratio or relationship between the destinations at A, its bases and totals, and the future total at the origin A. So effectively, we focus here on row A with the values 2, 16, 9 and 18. We take that and we create a new table for that row of destinations, and now everything becomes vertical. So if you focus on your new table, which is the yellow highlighted section, our objective is to take this row and transpose it into a vertical column, and we're going to line it up with its base totals and its future totals for destinations. So your base totals are 58, 57, 26 and 69, which you now line up vertically, and your future base totals, which are 72, 85, 41, 96, you line that up vertically. And effectively you take this relationship, which is a multiplication relationship, and you say that future. Now, once we have our information lined up vertically, we need to create some relationships in the in zone A's destination information. So effectively, 2, 69 and 18, zone A's destination information, needs to be multiplied by a factor. This factor is the relationship between the base and the future totals of destinations. So 72 divided by 58 respectively will give us the factor for A to A. So 1.24 is the factor from A to A, and it's derived from 72 divided by 58. This information is here in the yellow zone. We have achieved this factor of 1.24, so we take Tij, which is the destination trips from A to A, and 2 multiplied by 1.24 then gives us a new value of current Tij multiplied by Fij, which is the factor created from the base destination totals and future destination totals multiplied by the trips from A to A. So we get this relationship now that exists between zone A and its base and future totals in the destination direction. Now we got to take this and we got to do it for each of A to A to B, A to C and A to D. By doing this, we're now creating the destination factors. These 4 factors are totaled up. There you see by sum, you see a total of 65.58, and now we've got the base, the destination relationship. Now we've got to take this destination relationship and parlay or create a relationship with a future origin total of 91. So we do that by saying 2.48 divided by a total of 65.58 gives me a ratio, it's a very long decimal here, of 0.037859,515, and we similarly do it for the other 3 current Tij Fj relationships. That total must be 1. So this is the crucial ratio relationship between destinations and origins, and these decimals are going to be multiplied by 91. So for example, if we take this first long decimal here of 0.037 and multiply it by 91, get a value of 3. So that is the future value of A to A. So okay, we multiply out here, we get a 3, a 33, a 20, and a 35, and we multiply that, or rather that is the output of this new ratio relationship between destination and origin. So this 3, 33, 20, and 25, there's a rounding up relationship happening here, and these decimals have to become whole numbers. And when you total up these whole numbers, they must be 91. So some of them you'll round down and some of them you'll round up. So your numbers might not be the same as mine, but it'll probably be very similar. That is fine as long as you're only rounding up by 1 or rounding down by 1 for these 4 categories, and your total is 91. This is modeling. It is not perfect. It is as accurate as can be. So here we now have the final calculation from the first origin and the relationship created with the origin of 91 and the future matrix totals. So we present the new matrix at the bottom in green to show you that you take the vertical and you put it back as horizontal into your new matrix. So we've done the first destination to origin relationship, and we're now going to do each of the other ones as well. So similarly, row B or destination B is then parlayed into its own little table, and we keep the total base and the total future destinations as before, and we take row B and we multiply it by this factor that we create to get the new current Tij times factor. We total up these values, which makes 64.88, and by taking each of A, B, C, and D, the origins, we divide into that total and we get this ratio relationship with our future PI of 62, and we create our totals, ensuring that they are whole numbers and that they definitively total 62, and then we parlay that into a new matrix, into a horizontal row. Yeah. Doing the same thing for the third origin, we parlay destination row C into its own table. We create a factor between the base and the future destinations. These are our factors which do not change at all. We take our destination row C, multiply by these factors, and we create its relationship. We total it up and we say 17.38 divided by 96.97, and we get that first ratio, which we're going to multiply by our future P of 88 to get an answer of 16. We then do it for all 4 of our origins, and we get our future trips for our origins, which must total 88. They must be solid numbers, and we take that column and we create a horizontal entry into our new matrix, seeing there the future total of 88. And then our very last origin, which is destination row D, we do the very same thing, observing the future trips, parlay it into the new matrix, and we get our totals of 66. So now we've achieved our new matrix. And we can see that there's very small differences in the total base and total future trip matrix for origins 91 and 91, 62 and 62. And the question is, why is that? Very simply, we started with our destinations and we worked toward our origins. So obviously there's going to be a stronger relationship with the origins. If we look at the new future totals for the destinations, the gap is closed. If we look at 72 divided by 70, we get a difference of 3% accuracy, 6%, 12% and 5% respectively, which means that the Fratar method is actually very sensitive and a very accurate model. So now you are encouraged to go and do example 4 again. except to apply the Fratar method, and you are given a sample of what the answer will look like. Thank you very much. Bye bye.